Good day to you viewers. Hope your day has been good. You're welcome to our channel and your channel again. That's Supermatics. Today we will be solving some radical exponential equations. And these radical exponential equations are special. This one is special because the base is a radical, the exponent is a radical. Now let's get it started. To solve this radical exponential equation, we are going to make a representation like a transformation of variables. So we are going to let the exponent be another variable. For instance, we can say let the exponent, which is the square root of x minus 14. We can let it be a, so that the radical exponential equation that we have becomes the square root of 5 raised to the power of a as the new exponent equals to 125. Now you recall that when we have the square root of a, it is the same thing as a raised to power half. And what this means for the equation at our hand is that the square root of 5 can be written as 5 raised to power half, 5 raised to power half, then to the power of a, our transformation variable. And that equals to 125 can be written as 5 raised to power 3. That's 5 times 5 times 5. So on the left hand side, we can write this 5 raised to power half raised to power a as 5 raised to power a over 2. And that is because when we have a raised to power p, then raised to power q, it can be expressed as a raised to power p times q. So the same thing we did here, 5 raised to power half, and the exponent half times the exponent a gives a over 2. So 5 raised to power a over 2 is equal to 5 raised to power 3. And at this point, we equate the exponents since the bases are equal. So since the bases are equal, they can cancel out, and we equate the exponents. This means that we have a over 2 to be equal to 3. Then when we cross multiply or multiply both sides by 2, a is equal to 6. At this point, we are going to bring back what a is representing, so that the equation becomes the square root of x minus 14. That's a, and that's equal to 6. So we have changed the variable back from a that we transformed into, and we have changed it back to x, which is the original variable. And what we do next here is to square both sides. So that the equation becomes the square root of x minus 14, and that's squared on the left hand side, and on the right hand side we have 6 squared. So that on the left hand side, the square root cancels the square, meaning that we will be left on the left hand side with the square root of x minus 14. And that's on the right hand side, the square of 6 is 36, and we add 14 to both sides. So adding 14 to both sides means that we have the square root of x equals to 36 plus 14, and that's the square root of x equals to 50, which is 36 plus 14. Once again, we square both sides. So squaring both sides means we have the square root of x all squared, and that should be equal to 50 squared. Again, on the left hand side, square takes out the square root, so that we have x left. And that simply means that x equals to 2,500. Now that is the solution to the equation. The second equation here is another radical exponential equation. We have to solve the square root of 2 over 5 all raised to the power of x plus 1 equals to 125 over 8. So the first thing we do here is to apply this basic law of exponents and power. That is, when we have the square root of a, it can be expressed as a raised to the power of half. And this means that the left-hand side of our equation becomes 2 over 5 raised to power half, then everything raised to power x plus 1. And on the right-hand side, we have 125 over 8. So on the left-hand side, we are going to swap the exponents. I mean, if we have x raised to power m, then raised to power n, we can actually write it as x raised to power n, then raised to power m, so that the left-hand side becomes 2 over 5 raised to power x plus 1, then everything raised to power half, and on the right-hand side, 125 over 8. Then in order to clear the fractional exponent on the left-hand side, we can square both sides. When we square both sides, the left-hand side becomes 2 over 5 raised to power x plus 1 raised to power half, then raised to power 2 by squaring it. And the right-hand side becomes 125 over 8 raised to power 2. So that on the left-hand side, the 2 is going to cancel out the half. And that leaves us with 2 over 5 raised to power x plus 1. The fraction successfully taken out. And the right-hand side can be expressed, 125 can be expressed as 5 raised to power 3, 8 can be expressed as 2 raised to power 3, then all raised to power 2. So that we have 2 over 5 raised to power x plus 1. And the right-hand side, we can write 5 raised to power 3 over 2 as 5 over 2, all raised to power 3, then raised to power 2. This is actually because a raised to power m over b raised to power m can be written as a over b, all raised to power m. The next step we take is also on the right-hand side by applying products of exponents rule, one of the laws of exponents and powers, to the right-hand side. That's 3 times 2 in the exponent, so that the left-hand side becomes 2 over 5 raised to power x plus 1, and the right-hand side becomes 5 over 2 raised to power 6. And where we are now, when we look at the left-hand side, we've got the base as 2 over 5, and on the right-hand side, the base is 5 over 2. And this simply means that the bases are not equal here. So we are going to use a simple trick, a simple mathematics trick, in order to get the bases to be the same thing. And this trick is very simple. The left-hand side can still be maintained as 2 over 5 raised to power x plus 1, while the right-hand side, we use the reciprocal of 5 over 2. The reciprocal of 5 over 2 is 1 over 2 over 5, then raised to power 6. The reciprocal 1 over 2 over 5 is the same thing as 5 over 2. Now, when we have reciprocals, according to the law, one of the laws of exponents and powers, when we have 1 over k, 1 over k can be written as k raised to power negative 1. So we're going to be expressing the right hand side with this reciprocal as raised to power minus 6, so that we have 2 over 5 raised to power x plus 1, and on the right hand side we're going to have 2 over 5 raised to power negative 6 minus 6, so that at this point we can equate the exponents. Equating the exponents means that the bases must be equal. So, and since the bases here are equal, 2 over 5 on the left, 2 over 5 on the right, they can be taken out, so that we have x plus 1 equals to negative 6. Then we subtract 1 from both sides, so that x will be negative 6 minus 1. X is negative 7. If you have any question, comment, suggestion, please do so by placing them in the description box or in the link, the email attached to the description of this video. We look forward to you watching more of our videos, and please, to get updates as to when our videos get released, you can subscribe to the channel. You can also check through the channel for loads of exciting tutorials that we have already on the channel. Don't forget, our shorts are made every day, so stay tuned to the channel. Thank you.